आजको क्लास थाल्दिउँ ल. So today we'll start with capacitors. We'll continue with where we left. अस्ति हामीले पढ्दाखेरि मैले खाली basic definition of capacitance भनेको थिएँ. So मैले त्यही भनेको थिएँ कि capacitance is basically can like equate this to the charge stored in a particular thing. So capacitance is basically something that is storing some amount of charge. Okay, so charge movement is possible only when there is like potential difference, right? We have already learned that before. Like whenever there is potential, only then we have flow, right? Potential is equal to flow. मतलब potential difference छ भने only then we can say that there is flow in something. So if I say that मेरोमा current flow हुँदैछ भनेपछि, which basically means I have a system where there is a potential difference, right? So there is a particular potential difference. Because of that potential difference, there is flow, right? So we can directly relate the charge as like directly proportional बनाइदिउँ यसलाई. So let's remove this sign. So let's directly relate it to voltage. So if whenever there is potential, there is flow of charge. So more the potential difference, more the flow of charge. So like the two tank system that I always give you the example of. So if I say that one tank is completely full and one tank is completely empty and they are connected like this, now at this moment, at this particular moment, the flow will be very high. So the amount of water flowing from this full tank to the empty tank will be very high, right? So this is self-explanatory, right? It will be very high. Now if I say that the tank, both the tanks are like this is like this much full, right? The pipe is somewhere here, and this tank is not as completely full as before. Like it's not completely full, right? So now the flow will be a little bit slow, right? Slowly continues. Flow will be slow. Now which basically means whenever the potential difference is low, because we have a like small potential difference. Like if this is 5, this is not more than 10, right? So 10 minus 5 is 5 only. So the potential difference is 5, right? Now in this case, like this is 0. Basically this is 0 and full is 20. So 20 minus 0 is 20. So there is high potential difference which causes high flow, right? Basic flow. And this is like a small potential difference. So this will cause a very small amount of flow. So basically, so voltage will directly result in the flow of charges. So whenever there is more potential difference, there will be more charge flowing. So that's the reason why we have a directly proportional sign here. Now I remove the proportionality sign by adding an equal to that. So I put a constant here, and that constant is the capacitance. So C is given by Q over V. So capacitance of a conductor or a capacitor, whatever it is the charge over the potential, right? Kati charge cha over the potential, right? So this is very simple. This should be in your head, like it's very simple. Now my series and parallel, or I also did the series and parallel thing. So the only difference is that equivalent capacitance when it is in series, so it will be 1 by C1 plus 1 by C2 plus 1 by C3 will go on. So this is when it's in series. Series matlab it's one after the other. So capacitors are one after the other. So this is already done. So when they are in parallel, like when they are not one after the other, so they have like different branches. They have like totally different branches. They don't have a single branch. They are not connected one after the other. So its equivalent capacitance will be given as C1 plus C2 plus C3. So this also was already done. I had derived the formula as well, right? So this is done. Now the topic for today is capacitance of a parallel plate capacitor. So capacitance of a parallel plate capacitor. So for this we need to like bring back some topics or some concepts that we studied in previous chapters. So in electric field I had given you a formula, E equal to surface charge density divided by epsilon naught. So I think you remember this formula. So I had given formula with respect to surface charge density, another formula with linear charge density, another formula with volume charge density, I think. So now we just consider the surface charge density because we are considering area here, right? When we consider a capacitor, we are considering the area, not the volume. So we'll just consider this formula. But the only difference in the only addition you need to add to this formula is so a dielectric. So dielectric is anything that does not allow the flow of current, right? So it does not allow the flow of current between it. So if I have like a positive plate here and a negative plate here, right? It's very high, let's say medium voltage, let's say it's around 1000 volts, 1000 volt battery ma connect भएको छ यो कुरा, okay? And this is like air in between. Now this air will not allow the flow of current, flow of charge, right? The charge may accumulate here, they may accumulate, the charge may accumulate here, but this air will not allow it to flow from here to here unless the air is ionized by some extremely high voltage, right? So extremely high voltage can cause the ionization of air. So at extremely high voltage, air can conduct. Like best example is lightning, right? So air which is naturally non-conducting, air like conduct garden naturally, right? Doesn't conduct electricity, doesn't allow electricity to flow through it. But in some cases, air does. So one of the most like common example is lightning. Lightning hudaheri, what happens? The lightning from the cloud that is generated by striking of two clouds together, like falls on the surface of earth through air, right? There's nothing in between, there's air in between, right? So air is conducting electricity at that point. So that, why is that? That's because ionization is happening, because there's like extremely high voltage in lightning, right? In kilovolts, like maybe in megavolts, right? So voltage in lightning may be in megavolts. So this kind of voltage can ionize the air, right? Can ionize the air, and at that moment can conduct electricity. So that is a case where air conducts electricity. But when the voltage is comparable, when the voltage is like considerably low, air doesn't conduct electricity, and those kind of systems are known as dielectric systems. Dielectric systems, right? And those dielectric systems or medium, they are always present between the capacitors. So if this is a like two plates of a capacitor, positive and negative plate of a capacitor, there is a dielectric medium in between. So there is air or foam or whatever it is, whatever is required for a particular operation. So if I require air as a dielectric, so air will be present in between, right? So this is known as the dielectric medium, and this dielectric is represented by a symbol called K, capital K. It is known as the dielectric constant. It varies with different dielectric. Air ko value different huncha, foam ko value different huncha, अरू जुन जुन डाइलेक्ट्रिक छ तिनीहरूको सबै भ्याल्यू डिफ्रेन्ट हुन्छ. They'll have like totally different values. So the formula for E will be modified a little bit. E will be equal to 1 by K times sigma by epsilon naught. So this is the modified formula that you need to know in terms of capacitance. So when you talk about capacitance, you'll always talk about the dielectric, right? Because there is always something in between, maybe air, maybe any foam or whatever it is, right? It can be anything. It can be some any dielectric medium in between, and that dielectric is represented by this constant called the dielectric constant, right? This is surface charge density, this is permittivity of free space. Okay, so I'll write it in like a little bit neater. So E is equal to 1 by K times sigma by epsilon naught. Now here K is basically the dielectric constant. So K is called the dielectric constant. Dielectric constant, right? There's a dielectric constant. So what happens is, so there are two parallel plates. Parallel when they are facing each other like this, right? There are two parallel plates, and there is a dielectric in between, and the dielectric constant is K, right? There's positive, there's negative. They are connected to some certain voltage. We don't know the voltage. We don't want to know the voltage right now, right? So the electric field originates from positive to negative. Can anyone tell me? Will it rise from, will the arrow be this way or this way? Which one is the correct representation of electric field? Aditya Sridhar? Is the first one a correct representation or second one? So electric field will generate from positive or will generate from negative? Yeah, first one is correct. So it'll always generate from positive. It's like you have to yaad hunu parcha timarhai. This is a basic of electric field. So electric field always originates from positive and always ends up in negative, right? So there are two parallel plates. One is positive, one is negative. So electric field will always be towards negative, right? So this is the electric field, right? And this empty space represents the dielectric medium. Okay, this is the dielectric. This is the dielectric. Okay, so we came across a formula for E, right? Now we'll also come across a formula of potential. Potential is basically electric field into D. So D is basically this separation. So we just find the potential across this field. So potential across this field is E into D. So how much potential per length of the dielectric medium. So we come across this formula, Now we just substitute the value of E, right? This is the value of E, we substitute in this equation. So I'll write it again. So V equal to E into D. So in place of E, we substitute the formula that we like came across, 1 by K sigma by epsilon naught into D. So is this step clear? Yeah, it's clear, right? Okay, now what we do is we replace this now. Now what is sigma? What is the like formula for sigma? Sigma is basically surface charge density, right? So how do we write it? Come on, tell me. How do we write it? There's a formula for sigma, right? Surface charge density बनेगी क्यों? आदित्य, what's surface charge density? Aditya, can you hear me? I think disconnected. Okay. So surface charge density भनेको charge per unit area. So कति charge छ एउटा particular area मा. So that is surface charge density. So what we do is we just replace Q this sigma with Q by A. So I replace it Q by A into epsilon naught into D. So we just replace sigma, that is surface charge density, with Q divided by A, right? We just replace it by like this. So is this step clear? Aditya, Sritesh, can you hear me? Hello. Yeah, you can hear me, right? Okay. So we come across this formula now. We get the formula of V, right? And we know that capacitance is basically Q by V, right? अघि निकालेको थियौं हामीले. Capacitance equal to Q by V, charge per voltage. So what we do is we just replace the value. We just put Q up there and this value of V below. So what I do is I'll just replace all the values. Okay. Let me do it. So I know that capacitance equal to Q divided by what is V? V is 1 by K Q by A epsilon naught into D. So I can cancel this Q off. So this denominator will go to the numerator. So this will be K A epsilon naught divided by D. So this is the capacitance of a parallel plate capacitor. So this is a very, very important formula. Okay, so they can just provide you with K, right? They can provide you with area and D, and they'll tell you to find the capacitance of a parallel plate capacitor. So capacitance of a parallel plate capacitor is K into A epsilon naught divided by D. Okay, so K is the dielectric. So dielectric भनेको the thing that is in between the two plates, right? So what fills the gap between the two plates? So two plates of a capacitor, sir, right? What fills the gap between them? So that is the dielectric, right? And that dielectric can be anything. Can be like air, can be like foam, can be anything else. Okay? तिमी lag हुँदैछ. Yes तिमी lag हुँदैछौ. Aditya. So have you written this formula? Capacitance go, yo. Just write it down, okay? Ka epsilon naught divided by D. Ka epsilon naught divided by D. Okay? So this is not that difficult, but it's not that easy as well. Kasari arrive garnu, it's very like confusing. So first you should be aware about this formula, E equal to 1 by K sigma by epsilon naught. So this is the first formula you need to know. You need to also know that the potential across a field, potential across a uniform field of E equal to E into D. So now what you do is just replace the value of E, put the value of E here, right? And you'll get some value of V. And we know that capacitance equal to Q by V. So just replace Q and V, put the value of V here, you get the value of C. So that capacitance is the capacitance of a parallel plate capacitor. Okay, is that clear? Should be clear. Nice. So there is one more topic that we need to discuss today, and that is energy inside a capacitor. So energy. energy stored in a capacitor. So एउटा capacitor अगर charge छ भने, so if the charge capacitor, if a capacitor is charged, how much energy can it hold? So how much energy can it hold? We have to find it in terms of like capacitance के term मा हुन्छ. Capacitance will be in terms of Q and V, right? So we have to find the like energy stored inside a capacitor in terms of Q and V, or maybe C and V, or whatever it is. So if we can find it in terms of Q and V, we can find it in terms of C and V, because all these three are related. So if we can find Q and V, we can easily find C, right? So for that, what we do is, so now comes alikati integration usage. So bioscience लिनलाई अलिक साह्रो पर्छ यहाँ, but not that difficult. So we know that formula of capacitance is capacitance equal to Q by V. So we can rearrange this as Q equal to C into V, right? So I just took V to the other side and cross multiplied, or let's say I just multiplied with V on both sides. So I multiplied with V on both sides. So Q equal to C into V. So is this clear, Yasaman, your statement? Right? So this is clear. Now we know that, what do we know is, we know potential. What is potential? Potential is the amount of work done per unit charge. So I told you this earlier when I gave the tank wala experiment. So potential is basically the amount of work done to carry a single charge from one point to another. So how much energy or how much work are you doing to carry a single water molecule from this tank to another? So that is basically the potential, right? Now let us integrate this value. So what we do is, we don't know the value of Q, actual value of Q. We don't have a constant value for Q. We don't have a constant value of W. The only constant value is the voltage. So we are just provided a constant voltage, let's say. So we get Q equal to, W will be equal to V into Q. So what we do is, we put the W in terms of smaller values of W. So can anyone tell me what is a like integration term? If I want to write the smaller value of W, how do I write it? Aditya, can you tell me? Correct, dW. So we write it dW. So if we want to write a smaller value of Q, we write dQ, right? So we are writing in terms of smaller values of W. So what we do is, we write dW equal to V into dQ. So what we are doing is, we are trying to integrate this formula over the entire value of charge. So we are trying to not only consider or focus on one single charge or two single charge, right? We are trying to focus on the entire charge inside the capacitor. So entire range of values of charge inside the capacitor, right? So in a capacitor, we can have a range of capacitance range of charge from 0 to Q, right? So a capacitor can have charge from 0, it can go negative. A capacitor cannot have minus Q of charge, right? So it can either have 0, that is no charge at all, to the maximum amount of charge, that is Q. So this is the maximum limit of charge inside a capacitor, right? So what we do is, we integrate this now. So we integrate this. Now we integrate this Q over 0 and Q, 0 and let's say capital Q. Let's say capital Q here, dQ. So we are trying to find the work done or energy stored inside a capacitor, which can have a charge variation, charge density from 0 to capital Q. It can have charge ranging from 0 to capital Q, right? So what we do next, we try to solve the integration problem. So what we do now is, we continue with this equation. So dW integration is W, right? So if you integrate dW, you get W. V into, what is dQ? So what is dQ? No, dQ is not Q. What we do is, we know the value of V. What is V? Q equal to C into V, right? So V equal to Q by C, right? V equal to Q by C, okay na? So what we do is, we just replace the value of V here. V equal to Q by C. So what we do is, we just replace the value of V here as Q by C, integral of 0 to Q into dQ. Now since this Q and this Q are equal, we can integrate Q over there. So what we do is, 1 by C is a constant, 0 to Q, Q into dQ. So what is the integration of Q? Aditya, can you tell me? Hey, Aditya, very disconnect was. Aditya, can you tell me what is the integration of Q dQ? This small q only, okay? Yes, what is the integration of Q dQ? No, Q को integration क्यों? Yes. होइन डिक्यू होइन, मैले क्यू निकालेँ नि त, बिकज आई रिप्लेस्ड वी विथ क्यू बाई सी. ओके, सो वी voltage is basically q by c, right? So c equal to q into v, so v equal to q by c निकालेँ नि त मैले, right? So what is the integration of q dq? So what is the integration of x dx? What is the integration of, yes, x square by 2, not x square only, x square by 2. So this is 1 by c, q को integration is q square divided by 2. Tara we have a limit to go there. So we have a limit of 0 to capital Q. So after applying the limit, we get this as q squared divided by 2. So this is the energy stored inside a capacitor, q squared divided by 2c. So you can simply write it as q square divided by 2c. So this is the energy stored inside a capacitor. So mathematics nonlinear alikati saro parcha yo part. So forget about this. Just think about integration भयो. This is just the first step of integration, which you haven't done, you'll not do because you don't have maths, right? So just remember you're integrating q dq. So integration of anything like this, like x dx, yeah, the y dy, whatever it is, q dq is always q squared by 2 or x squared by 2. So it is q squared by 2 here because we have q here. So q squared by 2, and we are going over 0 to q. So charge can vary from 0 to q, right? It can go from 0 to q. So we put the value of q here. 0 is not considered because like when you put 0, it'll be 0 only. So just replace this small letter q with capital Q. So 1 by c, q squared by 2 minus another replacement is 0. 0 squared by 2. 0 squared by 2 is always 0. So we just consider 1 by c, q squared by 2. So q squared by 2c is the energy stored inside a capacitor. Okay. This should not be that difficult, but it's not that easy as well. So is this clear? Is it going in your head? Okay, so we can like derive a second formula as well. No need to derive, we just substitute it here. So what we do is, so हामीले थाहा छ capacitance को formula के हो. What is the formula of capacitance? Capacitance is basically q, charge stored per potential, right? C equal to q by v. So what we do is I replace the value of q as c into v. Q equal to c into v. So I have q squared, so this will be equal to c squared into v squared divided by 2c. C squared into v squared divided by 2c. So what I do is I cancel 1c here. So I get c v squared by 2 is also the energy stored inside a capacitor. So cv squared by 2, q squared by 2c. So you have to remember these two formulas. So energy stored inside a capacitor is q squared by 2c, and another formula, that is cv squared divided by 2. This is the energy stored inside a capacitor. So basically it is denoted as U. U is the energy stored inside the capacitor. It is 1 by 2 cv square, which is also equal to 1 by 2 q square by c. So now what we have a formula with respect to c, with respect to v, with respect to q. So because we know that capacitance is basically charge per potential, right? So we needed a formula with all these three values. So we have a formula with all these three values. So this is the energy stored inside a capacitor. So before the start of the derivation, I had said we can find any one formula and derive the next one. So what we did is we got this formula, right? We got a formula in terms of q and c. We got a formula in terms of q and c, and we derived a formula with respect to c and v. So this was just like substituting the value of q squared here and cancelling the value. We got this, right? So you can easily find this value and just derive it from here. So we got the formula for energy stored inside a capacitor in terms of c, v, and q. Right? Is this clear? Aditya, is this clear? Sritesh? Clear, na? Yes? SI unit of energy Q. What is the SI unit of energy? Joule. So it is joule. See the joule, yeah? Just put joule. Energy भनेपछि you don't need to consider anything else. SI unit is always joule. So SI unit of length, no matter what you talk about astronomical length. So astronomical length like खाली हामी light years भन्छ नि त हैन, but actually it is a subordinate of meters only, right? You are considering meter, then kilometers, then miles, then whatnot, then ultimately you go to light years and all those things, right? So the basic unit is always meter. So you can't like run away from this, right? So everything has a basic SI unit, like energy. every type of energy. Heat ko energy huna sakcha, ya ta energy possessed due to your motion, that is kinetic energy, half mv square, right? Energy due to your potential, that is your height from the center of earth, right? So all these energies are different forms of energy, right? एउटा type को form, यो same form को हैन, this is due to dynamics of a body. So dynamics भनेको when a body is moving, this is due to statics of a body when the body is stationary. All these are different forms of energy, but they have the same constant unit, that is joule. Okay, joule is the unit for energy. You don't need to rethink about electrical energy मा के हुन्छ, यसको energy मा के हुन्छ, wind energy के हुन्छ. No need to consider about that. Just think that energy को SI unit is joule every time. Okay, or you can just check dimensionally whether this is correct or not. You can every time, anytime you can do that. So whenever you like joule ko dimensions के हुन्छ and your q square by c ko के हुन्छ dimension, so that you can compare it. If they are equal, then you are correct. If they are not equal, you are not correct. So this is one of the ways to check whether your derivations are correct or not. So when you derive something, right, and you come to a final conclusion, let's say E equal to mc squared, so will the unit of this match the unit of this? So unit of energy is, unit of mass is kilogram, unit of velocity is meter per second, but it is squared. So it is kilogram meter square second square. So take any other form of energy, let's say potential energy, m into g into h. Okay, now let's say this is the energy we are considering. So mass is kilogram, g is just acceleration, acceleration is meter per second square, and height is just meter, right? So you get kilogram meter into meter square per second square. So these two are matching, right? So both left hand side is equal to the right hand side. So dimension of E is matching with dimension of mc square. So any energy, you can put any energy here. Okay, if you put kinetic energy, let's say kinetic energy half into mv square, so m is kg, then v square is meter per second square. So again you get kilogram meter square second square, kilogram meter square per second square. So you can put any energy there. Heat energy also, temperature energy, wind energy, solar energy, whatever you put here, you should get the units to be same, or else dimensionally incorrect huncha. And when something is dimensionally incorrect, you can't by any mean you can make it correct. Physically impossible चिजहरु चाहिँ dimensionally inaccurate huncha, dimensionally same हुँदैन both sides, right? So if you have a left hand side with meter, right, if you have left hand side with length, length cannot be equal to mass, right? So you can't write L equal to m, because यहाँ length भनेको meter हुन्छ, mass भनेको kg हुन्छ. So dimensionally they are totally incorrect, right? Mass is not equal to kg. So you can never say that length of something is equal to mass of something, right, when you're considering the unit. But if you just consider the magnitude, let's say 5 meter is equal to 5 kilogram भन्न सक्दैन नि त हामी, right? We can't say 5 meter is equal to 5 kilogram, but we can say 5 is equal to 5. So if we just consider the arbitrary values and just the numbers and not the units, we can come to a logical conclusion. But this elementary levels 7, 8, 9, 10 हरुले पढ्ने कुरा हो. So 12 को लागि हैन यो. This is अलिक एडभान्स जानुपर्छ हामी. So whenever you think you are getting your answer as incorrect or something, just try to match it dimensionally. Dimensional analysis गरेर try to match it. If the dimensions are matching, you are correct. Most of the time you will be correct only. Okay. So these are the two